We're going to go through 3 sample questions now. The first one says, if a man holds a 50-kilogram box at arm's length for 2 hours as he stands still, how much work does he do on the box? So this one's pretty easy. You've got your gentleman who's got a box. He's holding that box there. The box is not moving. We need to go back to our force and remember that we are applying a force in the upward direction. That's balanced by the weight in the down direction. So we can say work is equal to F times the change in the distance times the cosine of the angle. And at this point, we know that there is no change in distance. That goes to 0. So there is absolutely no work done. So the work here is equal to 0 joules. And that's the first of 3 problems. The second question, so there's the first question. The second question says, if a man holds a 50-kilogram box at arm's length for 2 hours as he walks 1 kilometer forward, how much work does he do on the box? So once again, now we've got our guy again. This time let's put a little hat on our guy since he's a worker and he's smiling. He's carrying a box, and we know that this time he goes from here to here, and that distance that he has is 1 kilometer. So he walks pretty far. We're going to draw all of our forces again. We have a force up, that is the applied force that he is using in order to carry the box. Down would be weight, and this time we'll put mg. And let's draw a little diagram. We know that the force is in the upward direction. We know that going to the right is that delta r. And the angle between the two is going to be 90 degrees. Let's go ahead and plug everything into our equation. F is equal to, W here. Let's go back and get rid of the F. W is equal to F times the change in R times the cosine of the angle. Our force is still here. We do have a change here, but it's cosine now of 90 degrees. Cosine of 90 degrees is 0, so he is doing 0 joules of work on the box. Yes, he is applying a force, which is counteracted by the weight, but notice that the angle between the force and the direction of motion is 90 degrees, so there is absolutely no work done for that one. The last question that we have is a little bit different. This last question says, if a man lifts a box, 50-kilogram box, 2 meters, how much work does he do on the box? So finally now we've got something that we can actually calculate an actual number for. We have our box. We know that he applies a force on the box in the upward direction, and we know that the box has a weight, and we'll call that mg. We also know that he lifts the box in the same direction, so we know that our change in distance here is 2 meters. Let's use our equation. Work is equal to F times the change in the distance, which is the displacement, times the cosine of the angle. The force he applies will be mg times delta r times the cosine of the angle. Our mass here is 50 kilograms. Gravity is 10 meters per second squared. We're going to multiply that times the change in distance, which we know is 2 meters, and times cosine of 0 degrees, which this crosses out to be just 1. If we go ahead and do our math, we end up with a work of 1,000 joules. And now we are done with the 3 questions for this section.